It's great to be here. I would like to talk to you about the topic of circularity in HVAC from the Dutch perspective and the experiences that we as the Dutch Association have with this topic. I would like to do that on behalf of Binnenklima, which is the association of manufacturers, suppliers, and service organizations in the field of air handling, ventilation, heating, and cooling. We are committed to achieving a healthy indoor climate in all buildings at any time and for everyone. So when we look at the Dutch environment, the environmental performance of buildings has been a part of the Dutch building codes for a pretty long time now. Our experience, in short, is that we have been pioneering with ambition, but it's also led to a certain amount of fragmentation. For manufacturers, this means that the reality is a maze of rules, tools, certificates, guidelines, you name it. So in short, it's quite a bit of a headache. So what can we learn from this Dutch experience, and what are we asking Europe in this specific topic? I would like to briefly introduce you to the Dutch building codes. As you might imagine, we have some requirements on the energy performance of buildings, but we also have requirements on the environmental performance of buildings. These requirements have been in place since 2013, but it's only since 2018 that there's actually a numeric value in our codes that you need to abide by. So this environmental performance of buildings, let's call it the MPG, how we call it in Dutch. The current requirement is that the MPG should be less than or equal to 0.8. What does this actually mean? The 0.8 is the sum of the environmental costs of all building materials expressed in the so-called shadow costs. How I would like to explain this value is that you are not allowed to spend more than 80 cents per square meter of your building to compensate the environmental effects of your building. That's essentially the idea of the value. So it's a summation on a building level of products and materials used to compose the building. So you need a data source for that. And the data source in the Netherlands is the Dutch Environmental Database, or the Nationale Milieudatabase, how we say it in Dutch. This database contains so-called environmental profiles. And these profiles can be separated into three categories. Category 3, which is a generic value. Category 2, which is an association aggregate value, which you need an LCA for. And we have the manufacturer-specific value, which is the category 1. The category 3 profiles, they're imported from EcoInvent, a database for these types of values. In the Netherlands, we have chosen to add an additional 30% penalty on the already imported generic data. Compared to some other countries, this 30% is relatively conservative. There are some countries that do even 100% markup on this value. The methodology to assess this is the Dutch assessment method for the environmental performance of construction works. It's largely based on the European standard EN 15804. Of course, it could have been fully based on the standard, but the Netherlands wouldn't have been the Netherlands if they didn't make it something of their own. So basically, it's a methodology for building level environmental performance that consists of products and materials as a summation. The value that I just showed you, the 0.8, in of itself, that value is not strict enough for manufacturers to develop these EPDs, because you can basically achieve this value if you only use the generic category 3 data. So then you might wonder, well, if the generic data is already enough, why doesn't the government tighten that value even more? Well, that's because we've had some issues with this methodology. And the first issue, if we remember the principles, so we go from generic Dutch EPD to the manufacturer-specific Dutch EPD. Let's call it that process. The theory is that if you do that, you get rid of the 30% markup. But as Otto also mentioned in this presentation, we've had a case where a manufacturer, as ambitious as he was, developed this Dutch EPD, but the specific value of this heat pump in this case was 11 times worse than the generic EPD value that we had in our database. So there's a difference between these generic values and the specific values, and that's because of the differences in scope and the so-called product category rules. That's one type of problem. The other problem is that when we look at the manufacturers that both have manufacturer-specific EPDs, in this case, we have a similar product. And despite this product being similar, we've seen that in this case, product X has a more than 2.5 times better EPD value, so to say, than the other product. That's curious, and that's especially curious because, as you all know, our industry is an assembly industry. We don't make the sheet metal, we buy them and we make products of those. So when we further dive into the components of these products, we find that most likely they use the same components. And in this specific case, we've seen that the environmental impact of those same performance on the one case is enough or higher than the total environmental performance of the other products. And we're talking most likely about the exact same components here. So not only do we have differences in category 3 and category 1 products, we also have these inexplicable differences between these manufacturer-specific EPDs. Then circular economy happened. Because you might imagine, well, if he has so much issues with these EPDs, why not just postpone it? Well, specifically in the case of circular economy, we see that there is increasing attention for this topic from a European level, in European legislation and policy, but also in Dutch legislation and policy, where we have targets for 2050 and 2030, and I imagine you might have those as well. Next to these developments, we are also in the transition of zero energy buildings to zero emission buildings, which also raises questions on circularity of products and buildings. And finally, my favorite, the CSRD. Even though right now it doesn't state any concrete or specific requirements on circularity, somehow this started the discussion on the client side about the sustainability and circularity of their procurement strategies. So increasingly, circularity is becoming a requirement in procurement, both governmental and private. So while the Dutch environmental performance of buildings indicator in of itself is not strict enough to incentivize manufacturers to develop these EPDs, we see an increasing demand from another reason, which is that clients are using this as sustainability criteria. So when we know that this is a situation, we ask ourselves then, do we know what circularity is in our industry, in the HVAC industry, and how does this Dutch system for the EPDs function? Starting with what is circularity in HVAC, it might not surprise you that we don't have a definition for that and we don't have an agreement on the scope of circularity. I've already given some brief examples on the Dutch EPD side of the equation, which is that there's a high risk of manufacturer-specific LCAs or EPDs being worse than the generic data than we already have. And there are also some inexplicable differences between manufacturer-specific EPDs that both have done this life cycle assessment to get rid of that 30% markup. So if this is the situation in the Netherlands, we of course look at our European colleagues, like what is going on in Europe and can they help us to get out of this situation? Unfortunately, we have found that also on a European level, it is mentioned in many policies, and I think over the last couple of 2 days, you've heard a lot of those policies, but there is no European standard or European guideline or anything on this subject. And unfortunately, we've also found that when it comes to the discussion of EPDs, it is still a discussion about EPDs. So there is no harmonized or designated methodology for the HVAC industry, and there is no reliable background database for these types of products. So this slide can be summarized essentially with one word, and that is uncertainty. All the while, we have a whole life carbon global warming potential that needs to be implemented in 2 years' time. Clients are increasingly asking for arbitrary circularity criteria. Clients are increasingly asking for these EPDs because their procurement strategy demands it. So manufacturers are forced into this uncertainty, and this is the moment that we ask ourselves, what are we doing, genuinely? So what do we see what actions do we think need to be taken in order to get at least the discussion about these European EPDs going? So our observation is that our product is made for a specific function, and that is to deliver a healthy indoor climate. That function is fulfilled by a product that requires materials to be built and a product that requires energy to operate. Our observation is also that right now, currently, for certain products, there's discussion going on whether or not to use this energy use and to add it to the material use of the product in a form of singular EPD. We have an idea about that. This product can be used in different functions. So in this case, this air handling unit can be used, for example, in a school building or in an office building. So the materials in production of this unit is the same in both cases. However, as you might imagine, the energy use should be very much different in both cases. So while it is the same product, the emissions are dependent on the building in which it is applied. And also, if you do this, if you involve the energy use of the product in the EPD itself, it discourages manufacturers to perform, to improve the material side of the buildings, but it's relatively better to do, improve the efficiency of the products. So we think it's illogical to include the emissions that a manufacturer has no control over to a singular declaration of something that a manufacturer does have control over, the materials and the production, in short. So about the EPDs, our advice, our question, our plea to Europe, please keep the EPDs focused on material and production. Exclude operational energy use. It's arbitrary. Pick a methodology which is suitable for products that are assembled and that use energy to operate. We all know that the background of the EPD methodology is in construction materials and not HVAC systems or technical building systems. Harmonize the EPDs across member states. Develop and maintain a reliable and representative material database for our products. We shouldn't have a database for various countries with various values. And finally, also on this topic, consider a separate material database for different product groups. Should we have the same database for construction materials and for technical building systems? That's a question that we can ask. But that's one side of the equation. How do we handle the circularity aspect of the equation? So where there is discussion on the definition of circularity, there seems to be an acceptance on what strategies help or improve circularity. Let's call those the R strategies or the R ladder. Step one, dear Europe, pick an R ladder. Pick a common R ladder. Let's take the R9 for example. That's the first one. We standardize an R ladder. Then we separate the different strategies into the different aspects of a product's life cycle, so we map them. In this case, we know that certain R strategies influence the R&D and the design of a product. We know that another group of strategies influences the product when it's already in operation or in use to extend its life cycle. And finally, we have certain strategies that are in effect when a product is already decommissioned. So we know this now. And finally, what we need is to develop a framework of methods and design principles, so this is in the first category of A, that facilitate life cycle extension and strategies to minimize end of life. The reason why we preach for this framework is because our observation is that in a lot of European countries, there are already talks and examples on service strategies in use to extend the life cycles. Refurbishment, repurposing, retrofitting, these are all very good strategies that we can take right now to decrease the carbon footprint of the products. However, it becomes a problem when there's an expectation on the manufacturer side to make decisions on the R&D and design of the product. Because the situation can arise that there are different expectations in the Netherlands, different expectations in Germany, France, you name it. So we need to find a way to make different products comparable when it comes to these design principles that help or facilitate the circularity of a product. The sooner we can start thinking about those design principles and how to value them, the sooner we can start a discussion on the impact our products can have in that. There's a very interesting graph that unfortunately I don't have in this presentation, but it's something to think about. If you plot the energy efficiency of our products next to the regulatory development on the energy efficiency of our products, it's almost one-to-one. When standards become stricter, the products become more efficient because there's competition around it. And we need to find a way to start and make competition on circularity as well, and we cannot do that if every country has their own standards. Thank you very much for your attention.